So if we put all of them together, that is the resistance that we do get. Now, if we look at the resistance, total resistance for this circuit, and we look at the total resistance for this circuit, there's a huge difference. The total resistance for this circuit was 21 ohms. Total resistance for your parallel network is 0.75 ohm. Once we have total resistance and we know total voltage, we can work out total current flow through the circuit. Formula. If we want the total current, we need to take total voltage, which is 12. Total total resistance is 0.750. Yep. And let's look at what is the difference here. 12 divided by 0.750 . 12 divided by 0.750 ohms gives you 16 amps. That is a huge amount of current flowing through the circuit. If we compare the two, parallel circuits tend to draw a little bit more current. Series circuits draw less current. This series circuit drew 0.571 amps. This one draws 16 amps. A huge difference between the two. So now we've covered that part. Let's go on to the last part, which is how do we calculate resistors. So if we have a resistor in our hand and we want to find what the resistor that we will be discussing is a 4-band resistor. It is exactly the same as a 5-band resistor. It's just one extra band on the calculation side. First band and second band gets added together, and the third band actually gets multiplied. First band and second band gets added together, and the third band gets multiplied. The fourth band, which is the furthest away from the other three that's all together, is called the tolerance band, and that is expressed in a percentage. So if a resistor has a value, for example, of 100 ohms, and it's got a silver band which represents 10%, then the manufacturer has allowed for 10% of tolerance. Let me explain. 100 ohm resistor, so the value could be a little bit less, up to a maximum of 90, or it could be a little bit more, up to 110 ohms. Anything more, and then the resistor is out of value. Let's go to some examples. We have a resistor with the following color code: brown, black, black, and red. First band, second band, third band, and fourth band. How are we going to find out what the value is? There is a formula, and it goes as following: 0 represented by black, 1 brown, 2 red, 3 orange, 4 yellow, 5 green, 6 blue, 7 violet, 8 grey, 9 white. That is quite a mouthful. What students have done in the past, they have used a little rhyme and memorized it to remember these color codes. But for now, we have written it down for you, and let's look at the value of this resistor. Brown is a 1, black is a 0, and we have another black. Black multiply is 1, so that is 10 ohms. And the red as a tolerance band. Red is your tolerance band, so that's 1%. Let's go to the second resistor. Orange, which is 3, yellow, which is 4, and red, which is times 100. And we've got gold, so 5% tolerance. Let's go to our third example. V is for violet, which is 7. Black is 0. Oh, sorry, blue. Where's blue? Blue is 6. And orange. Orange is 1000. And you've got silver as your silver is 10%. It is quite easy, as I said, if you follow the formula, you can't go wrong. Let's do a recap of what we've learned today. We've learned about the function of a resistor. We've learned about where do we find them. We've also listened to an explanation of how to calculate resistor in a series circuit as well as a parallel circuit. And then finally we've also learned in that part of a formula called the Ohm's formula. And then the last part is a 4-band resistor calculation. If you find the resistor of 10 ohms or 34 ohms or 76 ohms, what you can do to verify is, if you know how to use a multimeter, put the multimeter on the ohm scale. Take the two leads, the positive and the negative lead, put it across the resistor leads, and also make sure that you don't touch it with your hands. You should get the same value on the multimeter as on your calculation. Thank you for listening to this demonstration, and we will be going over to the assessment part of this course. The assessment part can be done in the classroom environment as well as on the internet. Now what we've done is we've given you, the student, a chart like this to show that this is the questions that you'll be asked in the exams. Now there's 10 questions, and I'll just quickly demonstrate these questions to you and explain them. First question, what is the function of resistor? And I basically just want the prime function of the function of the resistor. You can add anything else that would just be in your own benefit. Where do we find resistors? Give examples. As I've explained to you, there's 3-4 different places where you will find them. How many bands on the resistors that we discuss? Remember we were talking about 4 bands and 5 bands, but we've discussed the band resistor. What type of electrical circuit can we use resistors in? We discussed 2 types of resistor circuits. Can you remember them? What's their names? And then I've given you a few examples of resistors with these type of values. You need to calculate them out for me. What is the color code for a 10 kilo ohm resistor? 10 kilo ohm, 1, 0, 3. So you will have that color, and that color. Brown, black, and orange. What does a red color mean in the tolerance band? Tolerance band, right over there. What does gold color mean in the tolerance band? Right on the far side. What is the formula for calculating resistors in series circuits and parallel? Remember these formulas? Make sure you memorize them. You'll be using them in your exams as well as for the rest of your life in an electronic career. The pass mark for this assessment is 50%. So good luck with it, and I know you're going to make a success of it. Thank you very much.